你有买手机？
没有，
你可能会很容易丢掉那个电话。姐姐用什么方式丢掉？这几天没相处就会都跟他们花了很久。
Hello, good afternoon. Okay, put your phone down. Still busy? Still busy or still very busy? Very busy. Okay, so sit down, relax. So listen for 1 hour plus for this. Okay, put your phone down. Alright. So this chapter is about system dependability and critical system. Alright. So what you will learn today, critical systems, dependability, how to achieve dependability, availability and reliability. So these two are related. Safety and security. Okay. So first topic is critical system. So what is a critical system? You may have heard of this before, critical system. Alright, here says critical system is a system whose failure can result in significant economic losses, physical damage, or threats to human life. That means cause harm to human life. So a critical system is a system, if this system fails, can result in significant economic losses, can cause physical damage, okay, and also it's also possible to cause harm to human life. Okay, failure. Okay, so let's understand the meaning of failure in this chapter. Failure means the system does not deliver a service as expected by its user. So if a system does not deliver a service as expected by its user, it is considered a failure. Failure means there's no service to the user. So there are three types of critical systems: safety critical system, mission critical, and business critical. Okay, so I repeat, there are three types of critical system. So the first one is safety critical system. So there are many safety critical system. So safety critical system, okay, so failure may cause injury, loss of life, or major environmental damage. Okay, so repeat, failure means the system does not deliver a service as expected by its user. So examples of safety critical system: airbag control system, car reverse control system. So airbag control system is a system, okay, it's a system where you will release an airbag, okay, when a collision is detected. So if this system fails, okay, and does not deploy an airbag during collision, so this can cause harm to the human user. So car reverse control system, okay, so when we reverse our car, so when you reverse and close to an object behind the car, you may hear a beep sound. So if this system fails, that means the system is supposed to emit beep sound, but it doesn't. Okay, so can cause damage to the car, may also cause injury to the driver if the speed is high when you are reversing. You are reversing at a high speed. Alright, so these two are examples of safety critical system. Okay, can you give me one example of safety critical system? So if this system fail, okay, it can cause injury, loss of life, or major environmental damage. So nowadays there are a lot of safety critical system. Microwave is a safety critical system. Okay, microwave. So if the microwave is running and you open the door, okay, so the system should automatically cut off the power. Okay, but if you open the door, the system fail to cut off the power, this can cause danger to the user. So the third example is microwave oven. Okay, any others you want to add? So now let's look at the other one. So the other one is mission critical system. A system failure may result in the failure of some goal-directed activity. Okay, example of mission critical is GPS. So we use GPS when we want to go from location 1 to location 2. So if the GPS system fails, okay, you may not reach location 2, okay, or you may take longer time. Okay, same for aircraft navigational system. Okay, so aircraft navigational system is also guiding the plane, okay, to fly from one location to another location. Okay, so if this system fail, okay, so the plane may not be able to reach the destination. All right. Any other example of mission critical system? So mission critical system, a system failure may result in the failure of some goal-directed activity. So when we are using GPS, our goal is to go to location 2. Okay, so aircraft also, the goal is to fly to another country. Another mission critical system is a USB network. Okay, a USB network, the wired network and the wireless network. If the wireless network fail, you will not be able to take your attendance. You come here, you attend the class. Okay, one of the goal is to learn what is the lesson and also to take your attendance. Okay, taking attendance is one of your goal of coming here. So if the wireless network fail, you will not be able to take your own attendance. Alright? Right. So the third type of critical system is business critical system. System failure can have serious consequences for the business. So examples of business critical system is e-commerce website. So if e-commerce website fail, then buy and sell transaction cannot be carried out. Okay, customer want to buy, will not be able to buy. So to the e-commerce website, it is a loss of income. Online banking system. Alright, online banking system, we use online banking system to do financial transaction. So if online banking system fail, that means we cannot transfer money or we cannot make payment to a particular company. So let's say, how important is this? Let's say today is the deadline for you to pay fees. So happen that system fail, banking system fail, and you are not able to make payment. And this can have serious consequences to you. Okay, so for business, company A need to pay to company B. If today is the deadline to make payment and you are not able to pay because system failed, okay, then company may charge you penalty for late payment. Okay. ERP system. So ERP system is also a business critical system. So who use ERP system? Honda, Perodua, IKEA, all these big organizations, they are using ERP system. Let's say Honda. Okay, for Honda, they have ERP system. You can go to any branch to service your car, they have your record. They are able to retrieve your record. Alright? So when you bring your Honda car to service, so you have to check in the car. So they have to check in your car by entering some data into the system. After check-in, give you a receipt, then only technician can service your car. So if the ERP system fail, they cannot check in your car. Okay, they cannot check in your car, so technician cannot do the service. Okay. System fail. Okay, system fail. People are there, technician are there. Okay, so if data is not entered into the system, they will not carry out any work. This is big organization procedure. So that's why for business critical system failure can have serious consequences. Okay, any other examples of business critical system besides e-commerce, online banking, ERP? Online shopping is under this one, e-commerce, online shopping, Lazada, Shopee. Food ordering is under e-commerce. Okay. Okay. So now causes of system failure. So what are the causes of system failure? Failure of hardware, failure of software, failure of operation. So failure of operation can be due to accidentally deleted some important system files, or system has not been configured correctly. Alright. So these are the 3 possible causes of system failure. Okay. So when hardware fails, system fails. Okay, if hardware fails, system definitely fails. Do you still remember this? When you study, I think this is during your year 1 year, you study about information system. So information system, there are 5 components, correct? Hardware, software, what else? Database or data. One, two, three, 4. Okay, people. Correct? Still got one more. Procedure. One more.
No.
Okay, the network. Hardware fail. This one should out. If hardware fail, this one will be out. Software fail, out. Database fail, also out. people are not doing the right thing, not configuring the system correctly, can also cause system failure. There is a chance, okay? There's a chance where people can cause system failure, okay? If the people hired are not qualified enough to handle system, okay? Procedure. So procedures are written documentation that tell people what to do. So network fail. If network fail, some part of the system will not be working. Some system may still work, some may fail. What will fail is that you can't exchange information or data between two workstations. But the single workstation can still work, but exchange of data will not be possible. Okay, so main causes of system failure are hardware failure and software failure. So hardware failure is because due to the end of life. Okay, so hardware has a lifetime. Hardware has a lifetime. So a particular hardware maybe can last for 5 years. Okay, or a particular hardware can last for 3 years. Particular hardware may last for 5 years. Like your laptop. If you use your laptop every day, how long can it last? I think maximum 8 years. That's the max. If you use it every day and usage is heavy, okay, how long can your laptop last? 8 years, I think is the maximum. So before you reach 8 years, okay, some parts already malfunction. Keyboard malfunction, on-off switch malfunction. So other parts will also be started to malfunction. Eventually the whole system dies. Okay. So software failure is due to error in the code. Alright. Okay, so these are the causes of system failure, hardware, software, and operation. So cause of failure. So what's the cause of failure? System need to be replaced. So this costs money. Loss of revenue and reputation. So system fail. When the system fail, can cause loss of revenue and reputation. Example. Okay, example when the e-commerce website fail. Okay, if Shopee system fail, there will be loss of revenue. Okay, so because people cannot buy and they cannot sell. Okay, so when people can't make any purchase to Shopee, it is a loss of revenue. Okay, no income during system failure time. Okay, so also litigation or lawsuit costs. Okay, so one company may sue another company. Okay, so for critical system, the cost of failure is often very high. Alright. So for critical system, you have to think of how to avoid system failure as much as possible. So you have to remember, you are after you graduate, you will be in the software industry. Okay, so one of the causes of system failure is due to software. You are involved in software development. Okay, so I have explained to you what is a critical system. So 3 types of critical system: causes of system failure, cause of failure. Alright, so now look at the next part, dependability. So in layman terms, In layman terms, system dependability refers to the availability, reliability, safety, security, and resilience of a system. So this means that a dependable system is available, reliable, safe, secure, and resilient. Dependable system. Okay, so the dependable system will operate as expected and that it will not fail in normal use. Can you give me one example of a dependable system? The system will operate as expected and then it will not fail in normal use. Laptop lah, is your laptop dependable? Is it available when you want to use it? Reliable? Safe to use? Will cause injury to you.
Cause stress lah.
How can your laptop cause stress to you? Shh.
When they give me compilation error lah.
Oh, that one is different thing. I'm talking about your laptop. Lang is still working. It's under resilient. Okay, still working. Okay, but sometimes a bit slow. Okay, it's working. Resilient, not fail. Okay. So the important point for you to remember here is a dependable system is a system that will operate as expected and you will not fail in normal use. Okay, in normal use. Like laptop, okay, desktop.
Like the ITT website.
That one has a problem here. Has a problem here. Reliability. Because of this problem, it caused this. Safe. Will not cause harm to you, okay? Will not cause harm to you. Secure. I don't want to comment. Resilient. If this is, if you doubt about this one no lah. Alright.
At least got one. At least got one.
So these two combined can affect the reputation. Can affect the reputation. So your profession that you are going to enter can also have an impact, has a reputation impact to the organization. Okay, dimension of dependability. Alright, so in layman terms, system dependability refers to the availability, reliability, safety, security, and resilience of a system. So a dependent system is available, reliable, safe, secure, and resilient. So meaning of availability. So availability is the ability of a system to be up and running and able to deliver useful services to the user when needed. Okay, so when you need to use a system, the system is up and running, so system is available. You read this. 1, 2, 3. Read aloud. Don't be shy. One, two, three. One more time. Read aloud. Don't be shy.
1, 2, 3.
No, not 1, 2, 3.
Too long cannot synchronize.
Follow me. Okay. Reliability is the ability of a system to correctly deliver services as expected by user over a period of time. Okay. Ability of a system to correctly deliver services. Okay, availability is up and running when needed. Read this one. 1, 2, 3. Read aloud.
To prevent or mitigate accidents, injuries,
System to prevent or mitigate
Okay, good. Next. Read aloud. 1, 2, 3.
The ability of the system to resist accidental or deliberate
attack.
Okay, good. One more. 1, 2, 3.
The ability of the system to maintain continuity of its critical service in the presence of disruptive events such as physical failure and cyber attacks.
Okay, good. Tell me what's availability.
The system will be assigned to the manner of 24 and 7. Before me 24 hours and 7 minutes. All
Shh.
this one.
Stop looking at your phone. Look here. One more time. Start from here. 1, 2, 3.
The
Ability of the system to be up and running and able to deliver useful service to users when needed.
Okay. One more time.
one.
Okay. Remember, up and running when needed. Okay. Remember these few words. Availability, up and running when needed. Okay. Start from here. 1, 2, 3.
The ability of the system to correctly deliver service as expected by users.
Over a period of time.
One more time.
The ability of a system to be delivered
Deliver service correctly.
information
Correctly deliver service.
Okay. Remember to correctly deliver services.
expect a user
Ah.
over a period of time.
Okay, so reliability, ability of system to correctly deliver services. Okay, next. 1, 2, 3. Start from here.
The ability of the system to prevent or mitigate accidents, injuries, and other accidents.
One more time.
The ability of a
System to prevent and mitigate the accident.
Okay, good. 1, 2, 3.
the ability
Of a system to resist accidental failure.
the ability of a system to resist the accidental or deliberate attack.
Okay, getting better. Okay,
One.
1, 2, 3.
The ability of a system
And to maintain continuity of its critical service in the present.
such as equipment failure and cyber attacks and executive.
One more time.
Maintain continuity.
continuity of critical service even in the event of disruptive.
Okay. It's now, I guess, if not 100%, maybe already 50% of this info is in your long-term memory.
Yes.
Okay, let's move on. So these are the dimensions of dependability, availability, reliability, safety, security, resilience. Dimension of dependability. Okay, So availability, reliability, safety, security, and resilience can also be described as. So this is just another way to describe what these 5 dimensions are. Okay, example, availability is the probability that the system will be up and running and able to deliver useful services. Okay, so the probability that system will correctly deliver services as expected by user. Since these 2 are probability, it can be measured quantitatively. And these 3 are judgment. Okay, so judgment. Okay, so other dimension of other dependability properties are repairability, maintainability, error tolerance. So the first 5 are more important than these 3. Shh. Please don't talk so loud. Okay, so now let's look at the cost of dependability. So let's look at the graph here. So this is the y-axis is the cost, x-axis is the level of dependability, low level of dependability, ultra high level of dependability. Okay, so here cost is low, here the cost is ultra high. So the cost of dependability is ultra high, the cost of dependability is low. Okay, so this system has high, we can say that this system has high availability, but it's unreliable. Okay, so the cost to build such a system is low, right? Developing such system, the cost is low. Okay, so this system where the cost is ultra high, this system is reliable, safe to use, secure, and available 24/7, 365. So the cost to build such a system is ultra high. Okay, so why ultra high? Because this system need to be available, need to be reliable, need to be safe, okay, need to be secure and resilient. Okay, building such system, okay, the cost is ultra high. So if the level of dependability is low, the cost of developing such system is also low. Okay, so cost increase exponentially when the level of dependability required increase. Okay, exponentially. So this curve represents exponentially increase in cost. It's not a straight line, it's a curved line. Let's look at this example. Okay, so which car has higher degree of dependability? You compare these 2 cars. You know which car has higher level of dependability. Okay. Availability, reliable. Okay. Available, reliable, safe,
Corolla better lah.
secure, resilient.
没有可以送，可以学校，可以。
There was one time I go to a motor show. Okay, motor show.
This month, sir, you also go this month?
This month, no. During MCO time, I went to the one in Setia, Sri Setia, Shah Alam. Got a car show there. Okay, so I go and sit inside this car, and the salesman talk to me. Oh, he says, this car no spare tire. Open the boot, show me there's no spare tire, so that you can put more luggage.
Wow, the salesperson very shoot himself in the leg.
我的有，我的有哎。
Listen first. He said this tire, if punctured, can still go for another 80 km. So enough. The distance is enough for you to find the nearest tire shop. 80 km can still run for another 80 kilo if it is discovered that one of the tire is punctured.
这个大家就好了。
So this is a level of resilience.
Not rim, not rim.
So which car has higher degree of dependability? Okay, you know lah. Okay. This car, the degree of dependability is ultra high. Ultra high. Who use this car?
The president of the US.
The US president used this car. Ultra high. So what's the cost? This is the cost. 15.8 M US dollar. Ultra high. Available. Reliable. Very safe. Okay, very safe. Very secure. And resilience. All punctured, still can run. Okay. They are willing to spend the money just to protect their president.
Bullets cannot pass.
Okay, so now you understand why cost increase exponentially when the level of dependability increase. Okay. How to develop dependable software or system? So the number one is avoid introducing errors. Avoid introducing errors into the system during development. So this is because error can cause failure. Okay, errors can cause failure. So design verification and validation processes, okay, that are effective in discovering residual errors in the system. So residual errors means remaining bugs. Okay, so remaining bugs in the system even after performing thorough testing. Even though you have performed thorough testing, they may still have some bugs in the system. So you have to find ways to find these remaining bugs. So design system to be fault tolerant so that system can continue working when things go wrong. Design protection mechanism that guard against external attack. So these are ways to develop dependable software or system. Okay, so last one is design protection mechanism. Okay, that guard against external attack. An example is ATM machine. Okay, so ATM machine, what you can see? A keypad, a screen. That's all you can see. Other parts are fully protected with alarm, with CCTV. Okay, so this system is highly protected. What you can see is the opening where you can insert card, just a small opening where you can take the cash, keypad, and the screen and some buttons. That's all you can see. Okay, so all others are hidden from your view. So that's the level of protection ATM machine need to have. Okay, so other ways to develop dependable software system are configure system correctly. So include system capabilities to recognize cyber attack and to resist this attack. Design recovery mechanism, okay, so that you can restore the system after a successful attack. Okay, achieving dependability. So how to achieve dependability? So keep backup servers and switch to backup servers automatically if failure occurs, right? So this means you keep two servers running at the same time. If one fails, then switch to the other one automatically to maintain continuity. So second is have different server using different operating system. So one server may be running Windows operating system and the other server is running Linux operating system. Okay, so don't make all your servers is running using the same operating system. This is because hackers may be skillful in one operating system. They may be skillful in attacking one operating system, but may not be skillful, have the skill to attack a different operating system. Right. So if both are running on Windows, okay, so likely these two will be, hackers will be able to attack these two successfully, and both server also down. Alright, so achieving dependability, these are two approaches. So the third one is, okay, achieving dependability continue. Okay, so process activities such as system validation should not depend on a single approach such as testing to validate system. So don't use just one approach to validate a system. Okay, so don't just use one approach to validate system, that is testing. Do not just use testing to validate a system. Okay, so this means that don't depend on testing alone to ensure system is free from errors. Something else need to be done too. What is this something else? So once we have developed a system, we normally do testing. Okay, we do unit test, module test, system test, thoroughly test it. Okay, to get rid of all the possible errors. So if you use testing alone, okay, if you are using testing alone, you may not be able to get rid of all the bugs. Okay, because bugs can cause failure. So you should have more than one ways to validate a system that it is bug free. Don't just rely on one method, that is testing. So something else needs to be carried out as well. What is that? You can do review, inspection. So inspection means ask a peer to use his or her eyes, go through your codes, okay, and see there may be potential logic errors, okay, where testing is not able to detect. Okay, so you can carry out code review. Okay, code review, ask your peer, not just one peer, 2 or 3, because if you only use one peer, he may miss out some errors. Okay, so more people can find out more problems. Just like usability testing. Okay, you just depends on one tester. Okay, you get few testers to help you to find usability problem, to find potential design mistake in your script design. Let's take a 10 minutes break.
你去上厕所？我去了。你要出去的，你要出去我就出去了。
至少，羽窝。 以为要借啊。
你抽到还是什么？我抽2个，我忘记拿那个卡去放，再见。应该是中了，我没有仔细看，我看到这纸条就放在那边了。对，你要买那个2个，哎，我今天考，我2个一起做。谢谢。我有记性。
我最后10点8个字我才可以看。
你7点半的，你是几点的 batch？
我是最后，我7点半那一 batch，我是最后一组的最后一个人。
难怪我们相差了。你那时候register，你先register到吗？然后后面才到我，所以是第一个register。对，所以就赶上那个最后一个人。哇，很惨。
然后我就7点半刚坐在那里，就打坐，
没有跟人家聊天。
我等所有人走了，我才跟我的朋友讲。
哦，为什么？
就是因为他们很吵，然后我就想说更多。
所以他就选同一个人，因为我们是同一天。
因为我们那个看的人他走出去了，
对，他鞋子很长，他鞋子就跟印度人，女生瘦瘦的，是瘦的。对，应该我们同一天，应该是同一个人。有笔的里面，
没有我们的时候他完全没有，就里面
有笔的，
他没有走进去的时候是7点多，然后一走进去就跟我讲是怎么的，他就问我有没有带笔，然后我本来想是可以去厕所拿钱，然后他一直说我就
结果快进去，最后
我就看到隔壁卡上一个笔一个洗，一个笔卡上
我本来想说取一个 A 的时候，没有想到
然后我还跟他讲，我找出来的话，我就把这个笔放在你在旁边啊。结果是最后一组最后一个。然后这个 Alice， 他我也不能要讲他那个 Alice， 没有，他就是完全没有给钱，我没有带给我的，对，这不是我跑错了，
结果你的账是一样的。你那个笔被前面的人顺走了过，前面人拿着走。看个10，这是一个题目，少一个。哦，check，我的 check 塞在中间。塞在这边。塞在底。你的 Steam Staff 和随便都有啊，都可以 chat 的，就都可以聊天。
就是你不要移这个，
移这个，
就只是移50，
就给它空一点。我不管移去哪里，再上一点。好像有一点方向有点错了。已经很急，应该放打横的，我在下面放一个打横的页。
这样子啊，那就打几片。
不过我有
不会，一个 chat 是还是
chat 有2个东西，试下。我觉得我的字非常，在 chat 上面的字就很不错。我跟你讲，我终于买了生日礼物给我朋友，台湾网站买的，用 credit card 买，然后我买了300多马币，因为那个东西对他来讲很有意义。我们差不多刚认识他就一直开始聊到现在，我就想着21岁比较重大一点就买给他，因为他算是很好的朋友。它是身体油，挂沙发，一张卡。我再想一下，我觉得好像有点。
这样你买什么给他？
身体油，就那种，就是他很喜
精
欢
油这样的。
body lotion。对。
然后有一个挂沙的吧，一个毕竟那个东西贵是吧？
一个 YouTuber 自己做的品牌，
就是那个没有。
我很喜欢这样子，然后我就知道你。
是那个你之前给我看那个。
可以看过。应该是有吧？应该是。
你那时候给我看，然后讲不哪一个。
不哪一个？
对呀，就不这个是什么，那个是什么。
对，就是因为它的网页非常的简洁，然后它包装一样，差不多。对。感觉不太行。太明显。
可以移下来一点。
整个帮你看。少了一个什么？漏了一个什么东西？穿这个还有一个东西。
Still have 2 minutes break time. If you want to take a screenshot, you can take a screenshot of this.
去吧，你也不得空。
昨天放跟你讲了，他昨天放跟我讲我疯，那我那个电脑，两个在我那个窗户可以弄死，然后他就讲我疯了。
我们是都不想上那个老师的课，即使世界毁灭了，都不想读。
如果只有那一间电脑是爆炸的，
不可以，然后他就会想要换那个什么。
下降全电脑中断，动歪了，这有可能吧？
所以你不要直接讲那个老师生病过来就可以了。
很坏耶。你会咬已经咬1年多。
就是因为你讲要全部什么全世界，就是那个全部电脑坏掉，但只是解决问题根源就好了。
问题根源是他，跟电脑无关是吧？对。昨天我们很讨厌老师都有不好的下场。我全部好的。
我没有，我不说话了，对不起老师。
就是很多个老师，我就不要讲谁了。
我不喜欢你，但是
讨厌他，你不要讲啊，上车啊，上车。
其实那个老师我觉得还好，就是你们讨厌他时，我觉得还好。就是中测那个老师我其实还好。
英文老师还是这个类似。
你们那时候那个老师是谁？
我们很多老师都超级不讲。真的？所以我才讲。
database 啊。
database 他去那个公司，然后还有一个英文老师是他自己本中文有多久？
英文老师哪个？
很久以前的英文老师，第一个英文老师。
那个，一直问问题了。
给我们做100题。
对。
讨厌他，然后他就这样。
那阿虚你还好，那个英文老师是那英文老师就这样，我不懂我讲什么。
你在讲什么？我也不懂你在讲什么。应该说他participants可以improve the chat。
可是那个 database 那个老师的确很
在3层。他6个。
那个我没有做看，可是真的很神奇看。
神奇考比较好，我们的威力很大。
有讲吗？
有啊，我们有。就是骂在群里面骂他，我们不懂你有没有？我的 record 全部不见了，换掉。
我的印象，我好像都没有什么参与。我好像都没有什么参与。
对，因为你不常看电话，但我们骂
然后
完
你们骂完，
你已经出来了。
那这个老师我的确很生气。这老师我确定我有参与，可是其他的不是。
你在哪边？等一下，这里讲。就是你要做保守，你可以真的抵到客户。如果说还是你这个成功在。你告诉我，这样到时候我就他们真的很情绪上来了。OK 啊，你看我放去打分的地方，哎呀，超没有很晚，真有，可能越来越少。你是怎么把它变小的？我们不一样的应该。
这不小，这小会萌啊！
那谁打和那边再放大？
可以的吗？
可以的话，这突然有个镜头出来的。我去看一下，我的是。结果你放回去。没有，就是讲老师，我们去学校还要派人来骂我们。我才讲一句，我都还没开始，他没开始骂他，他就跟我道歉了。竟然敢！确定来问我，我就有被无语的。
开心好开心。
怎么听你们会讲？
因为我不会在线。
Okay, put your phone on the table. Okay, put phone on the table, please. So dependability, there are 5 dimensions: availability, reliability, safety, security, resilience. So these are the 5 main dimensions: availability, reliability, safety, security, resilience. Availability and reliability, they are related. Alright, so let's look at this pair, availability and reliability. Availability is the ability of a system at a point in time to be operational. Operation means up and running and able to deliver the requested services. So reliability is the ability of a system to correctly deliver services as expected by user over a period of time in a given environment for a given purpose. So availability, remember this, is up and running and able to deliver services when needed. Reliability is the ability of a system to correctly deliver services as expected by user. So availability and reliability can be expressed quantitatively. So these two are related and can be expressed quantitatively. Example for reliability, if a system is available, if a system availability is 99.9%, so this means that over some time period, the system is available for 0.999 of that time. So this is some additionals I've added, okay, so that you can understand what is this 99.9% and what's this 0.999. So example for this 0.999 or 99.9%. So over a 30 days period, let's say in a 30-day period, system availability is, if availability is 99.9%, so over a 30-day period, this means availability is 29.97 days. So amount of time, downtime is 0.03 days. 0.03 days is equivalent to 43.2 minutes. Is this acceptable? Over 1 month period, downtime is about half an hour. Okay. So this depends on what kind of system is that. Okay. So this may be acceptable. So when you calculate, let's say over a 30 days period, availability is over 30 day periods, over a 1 month period, you say my system availability is 99.9%. So this means it is available 29.97 days. So downtime is 0.03 days, which is equivalent to 43 minutes. People ask you, what's your system availability? You say 99.9%. Okay, so downtime is just 0.03 days. People say, wow, what's this 0.03 days? You understand what's 0.03 days? You change the minutes. So the number you give must make sense. Okay, just tell people directly, you calculate is 0.3 days. 0.3 days, you tell, okay, it's 43 minutes. People can understand better. Okay, give a number where people can understand better, not 0.03 days. Okay, so if this is the level of availability 99.9%, so this means over a 1 month period, downtime is 30 minutes, about half an hour. Okay, I think this is acceptable. Okay, so for reliability, on average, 2 inputs in every 1,000 cause failures. So you enter 1,000 input, 2 will cause failure. So then reliability as expressed as a rate of occurrence of failure is 0.02, okay, 0.2%. So level of reliability is 99.98%. So this is fine. Alright. So how reliable is your system? Is 99.8%. So you may give an example. Let's say, okay, for 1,000 input, 2 may cause failure. That is 99.8% reliable. Okay, so remember, okay, so availability and reliability can be expressed quantitatively. Okay, so these two can be expressed quantitatively. Safety, no. Security, no. Resilience, also no. not in quantitatively. Maybe in other ways. Okay. Availability and reliability are closely related. So these two are closely related. So if a system is unavailable, then it is not reliable. So a system that's often out of service is unreliable. So availability affect reliability. So no availability means no reliability. Now look at these three: system fault, system error, and system failure. System fault may or may not cause system error. System error may or may not cause system failure. System failure means the system is not able to deliver a service as expected by user. That's the meaning of system failure. Okay, so you have to understand this meaning. Failure means system is not able to deliver a service as expected by its user. So why it is like this? So reason why system fault may or may not produce system error. System error may or may not produce system failure. Why? So reason is the faulty code is not executed because the way the software is used. Each time the software is used, not all codes in the program are executed. Okay, agree? The software is so big, there are so many lines of code. So every time you use the software, not all codes are executed. So which code are executed depends on what features you use. Errors occur briefly. Errors occur briefly. Example, a variable may have an incorrect value caused by the execution of a faulty code. But before this is accessed and cause a system failure, built-in error detection algorithm reset the variable to a value, so then there's no failure. So this means the system has a faulty code. Okay, extra notes I've added here. So this means the system has a faulty code which may generate an incorrect value which is stored in a variable. But before this incorrect value causes a system failure, built-in error detection algorithm reset the incorrect value to a valid value. Okay, so no failure. Okay, so there may be also other possible reasons. Okay, why it is like this. Okay, human error, system fault, system error, system failure. You read this one? Okay, you read this one. Read in your heart. Finish. Don't be lazy, read. What you read, I've translated to this pseudocode. all this, almost all this I've transferred to this pseudocode. Font may or may not cause error, error may or may not cause failure. So this example says broadcast weather every 1 hour. So this example is about broadcasting weather every 1 hour. So broadcast weather. So let's say the first weather broadcast is at 8 a.m. This is the first weather broadcast, 8 a.m. So next broadcast time. So next broadcast time is time plus 1 hour. This is system time. Okay, so this is system time plus 1 hour is 9 a.m. correct? So the first weather broadcast is 8 a.m. So next broadcast time is 8 a.m. plus 1 hour equal to 9 a.m. This is 9 a.m. is the next broadcast time. Huh? So repeat until escape key is detected. If time, this is system time. This is system time equal to next broadcast time. Okay, 8 a.m. broadcast weather. This is a variable. This is the variable. Huh? So this variable store the next broadcast time, 9 a.m. So repeat until. So if system time equal to next broadcast time, then broadcast weather. So weather is broadcast. Okay, time is 8 a.m. So next is 090. This equal to this? No, huh? This equal to this? No. So this loop keep running. System time keep increasing. So the system clock keep increasing. This is a variable. System clock keep increasing until 090 equal. So broadcast weather. Okay, broadcast weather. So next broadcast time is broadcast time plus 1 hour. So this is 090 plus 1 hour. So that means next one is 10. Correct? Correct? Can you follow? Alright. So this is a 9 a.m. is the next broadcast weather. 9 a.m. done. So next is 10 a.m. So next is 10. This one done. Okay, so wait for the system clock to reach 10 a.m. Then broadcast weather at 10 a.m. Next broadcast time will increase to 11 a.m. Correct? Then 12, correct? 13, correct? $2,300, correct? Keep increasing. 2,400, correct? Keep increasing. 2,500, correct? based on this formula. This formula will increase the next broadcast time. This formula increase broadcast time to the next hour. So 10, 11, 12, 13, 23, 24, 25, and so on. Okay. So now tell me, where is the fault? Where is the fault? Where is the error and failure? So can you tell me where is the fault? Which one is the fault? Which one is the error?
The fault is the formula.
Okay, this is a fault. This is a fault. Error.
The time.
This is the error. Okay. This is the fault. This is the error. This cannot be 24. This cannot be 2400. Okay, so therefore, this error causes no more weather broadcast failure. So this error causes failure. Okay, this error causes failure because this is system time. The system time cannot be after 2359 is 00, not 2400. Okay. So this is an example of fault, okay, a fault that causes error and error causes failure. Okay, availability perception. Availability is usually expressed as a percentage of the time that the system is available to deliver services. Okay, example 99.9% availability. So 99.9% availability, let's say over a 30 days period. Okay, so using a 30 days period, so this means system is available 29.97 days. Amount of time is 0.03 days. Okay, you don't tell people 0.03 days, you tell people 43 minutes. Alright. So loss of service in the middle of night is less important for many systems than loss of service during peak hours. Alright. So this slide is about availability perception. Availability perception. If the 43.2 minutes occur during this time, okay, it is not a good thing that happen if system is unavailable during this time. But if the downtime happen here, so the consequences is less serious, because this is the time where there are not many users. So this is the time where there are many users. Okay. Availability affect reliability. So if downtime happen here, okay, when people go to the system is not available. So people will say that this system is not reliable. So when is the downtime can affect the perception of availability. Okay, not many people are affected here, but there are many people affected here. Okay, people always go there, system down. Okay, Availability affect reliability. People say this system is no good, not reliable. Have you ever been to an ATM machine? Okay, you purposely walk 5 minutes to the ATM machine. When you reach there, out of service. Go on, not? More than one time, Okay. Happy or angry? Happy. Not happy, can I be happy? Okay, if the downtime is 43 minutes continuous, okay, it is a worst case. If the downtime happen here is 5 minutes, 5 minutes, 10 minutes, 10 minutes, 5 minutes, I think it's still fine. Okay, it's not continuous 43 minutes. Okay, still fine. The perception of availability is not that bad. Especially during MCO time. You are connected to the Wi-Fi, then disconnected, connected again, disconnected. So the disconnection is a short period of time. It's not very long, correct? Okay, if the disconnection is 30 minutes or longer, a lot of people will be unhappy. I think sometimes lasts for a minute, maybe lasts for 2 minutes. Correct? If lasts for 30 minutes, you are not able to submit your exam answer on time. Okay, so availability perception. If system is down here, the consequences or disruption is not serious. Okay, it is serious. Okay, if the unavailability happen from 7 to 11 p.m. Okay, so the length of outstage can also affect perception. Okay, so remember availability affect reliability. So if a system is unavailable, then it is not reliable. Okay, so reliability metrics. So how we measure reliability? So you can count number of failures per month or number of failures per year, or mean time to failure. So mean time to failure is the average time a system or component is expected to operate before experiencing a failure. So for laptop, what's the mean time to failure? I think the time is about 5 years to 8 years. Okay, so can last for 5 years to 8 years. 8 years, 5 years maybe if the usage is heavy, okay, can last for 5 years. If usage is low, perhaps can last for 8 years. So I have one laptop. Before MCO, usage is light, usage is low. So during MCO, heavy usage. After 1.5 years, the laptop died. It's about 5 years old. It's about 5 years old, and I have to get a new one. Before MCO, usage is low. Okay, use but not much. Okay, MCO time very heavy usage. Okay. Okay, so availability. Availability is important for non-stop continuous running system. So example, telephone switching system, railway signaler system. Okay, so this system, these two kind of system must run continuously. Okay, and must be available 24/7, 365. Otherwise, we will not be able to make phone calls when we want to. Can you give one example where a system must run non-stop? 24/7, 365? What system is this? Can you give me one? Google Drive, correct? Google Drive need to be available 24/7, 365 because you are heavily rely on the service. This system cannot afford to be down. Okay, for example, 5 minutes. Okay, if 5 is down for 5 minutes, I think you are very stressed a bit. So Google Drive, cloud services, okay, all this must be available at all time. Okay, now let's go to safety. So safety is the ability of a system to operate normally or abnormally without causing human injury or death and without causing damage to the system environment. So a safety system, whether operating normally or abnormally, okay, should not cause human injury or death. Okay, so software is extensively used for checking and monitoring software safety critical components in a system. Okay, so example, all aircraft engine components are monitored by software, looking for early indication of a component failure. So this software is safety critical, okay, because if it fails, other components may fail and cause an accident. So software are used in a lot of products now. Okay, safety and reliability. So reliability is concerned with components to a given spec and delivery of the system service. So conformance means we'll do it accordingly when instructed. So safety is concerned with ensuring system cannot cause damage irrespective of whether or not it conforms to a specification. So a reliable system can be unsafe. Okay, so a reliable system cannot guarantee safety. So this means a reliable system, if it delivers services correctly, cannot ensure safety. So reason why a reliable system is not necessarily safe is system operator may be issuing the right command but at the wrong time. So a technician pressed a button that instructed the aircraft utility management software to raise the undercarriage. So the software carried out the technician instruction perfectly. Do what is instructed but is unsafe. Example. Okay, so pressing a button to raise the undercarriage, raise the wheel. Okay, so you can press a button to raise the wheel. So what will happen? Okay, so what will happen if the plane is resting on the tarmac? Okay, so if the plane is resting on the tarmac, okay, the command to raise the undercarriage should not be allowed. Okay, should be allowed when the plane is in the air. So that's why a reliable system is not necessarily safe. Do as instructed may not be safe. So 3 ways to achieve safety for safety critical systems. Okay, so how to ensure safety for safety critical system? So design system to avoid hazard. Okay, example, a cutting system requires the operator to use two hands to press two buttons simultaneously to avoid the operator hands being in the blade pathway. So design system to detect hazard and remove it before result in an accident. Okay, example, chemical plants must be able to detect excessive pressure, and open the relief valve to reduce this pressure before explosion occurs. Anyone of you have a pressure cooker at home? Okay, so pressure cooker can cook food very fast, but dangerous. I have, but also they not use. Okay, have to learn how to operate. It has built-in protection. Okay, if the pressure is too high, a valve is released to release some pressure, so that explosion is avoided. But still they not use. Okay, so third way is built-in protection features in the system to minimize damage. So example include an automatic fire extinguisher in aircraft engine. So if a fire occurs, it can be controlled before it poses threat to the aircraft. So aircraft engine should have this, but car engine don't have. Okay, security. So security is the system ability to protect itself from accidental or deliberate attacks. Security is essential because most systems are now connected to the network, connected to the outside world. So security is an essential prerequisite for availability, reliability, and safety. Okay. So impact of breach of security. So impact of breach of security are confidential information is exposed. System may be damaged or corrupted. System become unavailable. Okay, cut short. Okay, how to improve security? So 3 ways to improve security: avoid vulnerability, implement attack detection and elimination, limit exposure. Okay, so to avoid vulnerability, try not to connect your system to the public network. So you have to make a choice between convenience and security. Just like our fingerprint, use fingerprint to unlock your phone, use fingerprint to log into a particular system. It's convenient. Okay, it is convenient, but is it safe? Is it secure? You have to make a choice between convenience and safety. Security, not safety. Okay, implement attack detection and elimination. So use virus checker to find and remove viruses before they infect the system. Okay, so limit exposure, design system so that successful attacks are minimized. Okay, and company must have a backup policy. Okay, finish. Exercise. Okay, dimension of dependability, availability, reliability, safety, security, resilience. Okay, so availability, remember the keyword up and running. Okay, up and running and able to deliver useful services to user when needed. Okay, reliability is system able to correctly deliver services as expected by user. System able to prevent or mitigate accidents. System ability of the system to resist accidental or deliberate intrusion. Resilience is system able to maintain continuity of critical services. Okay, exercise 1. This one, which dimension of dependability are important? So this question say which dimensions? That means you have to give 2 or more. No driver. Which dimension are important?
Safety.
Safety, safety. Safety and reliability is correctly deliver services. Okay, correctly deliver. Okay. So when you reach a station, must stop. Reliability, yes. Reliability? No need. Need you reach the station, train is out of service. You don't want to see this So which dimension of dependability are important? Security, your money inside, you have lots of money inside. Security. Make sure it's safe to use. Security. Where else? Availability. System is up and running when you want to make payment. When you want to make payment, system down. Angry, Security, availability, reliability, correctly deliver services. Have you seen this before? You go to the ATM machine, you want to withdraw 1,000, the system says, please key the lower amount. Seen this before?
We don't have that much money.
Anyone? You key in 1,000, you want 1,000, but system say key the lower amount. Don't ask for 1,000. I can give you a lower amount. Key in the lower amount. But to know that doesn't tell you what's the lower amount. I hate this message. In HDI, this is not a good message. What's the lower amount? What do you mean by lower amount? I want 1,000. Key in the lower amount. Lower amount, 800. I key in 800 also. This message out again. Then 600 out again. Might as well you tell me what's the lower, what's the max amount I can withdraw. I lower, I key 100, 800 cannot, 600 cannot, I get fed up. So in HDI, this is not a good message. Alright. So for this topic, what's the reason for this? Is it for the dimension of availability, reliability, safety, security, resilience? This one. So remember, availability affects reliability. ATM machine, have you seen people go to a machine and fill up the money? Fill up full of cash. Okay, so after 1 or 2 weeks, amount of cash will be low, correct? When it's first filled up, amount of cash is high. After being used for 1 or 2 weeks, amount of cash is low. Alright. So when the amount of cash is low, it's low. Okay? Depends on which bank. Some bank will show you this. Okay? Public bank will show you this. Please key in a lower amount. I don't know whether or not they have changed the message. Okay? Please key in a lower amount. The reason for this is it because of this, or this? Which one? So when low, let's say low is 10,000 left. Here got 1 M. Here got 1 million. Okay, now after use 10,000 left. So if you still allow people to withdraw 1,000, if 10 people arrive and withdraw 10,000, 1,000, the 11 people when arrive will see out of service. So if limit to 200, max is 200. So how many people can this machine service? 50 customers, correct? Can service 50 customers. This one, the worst scenario is can service 10 customers.
50 and 10 customers.
You go there, limit to 200, can service 50 customers rather than can service 10 customers. So customer numbers 51 will see out of service. This one, customer number 11 will see out of service. This scenario is better than this, correct? This is a better scenario compared to this. So therefore, the reason for this is to increase the level of availability. What's the time?
2.
2.